In right triangle PRT, angle P is 90 degrees. Altitude PQ is drawn to hypotenuse RT. RT is equal to 17 and PR is 15. Determine and state to the nearest tenth the length of RQ. So this is a classic Geometry Regents question, and what they're really asking for is whether or not you are familiar with the geometric mean equation. So let me set this up for you guys. Whenever you have a right triangle such that you are drawing an altitude from the 90-degree angle to the hypotenuse, what you are doing is you are forming essentially three similar right triangles. Now, the altitude will partition the hypotenuse into two different segments. Now, I don't know what the proportions of the segments are, but let's call the one portion of the segment there A and another portion B. What happens is the products of these partitions will always equal to, let's call the altitude C there, it will always equal to the altitude squared. And we call the value of C there the geometric mean between A and B. So let's try to use this information to answer this question here. We're trying to solve for RQ. So let's call RQ X. If RQ is X, then TQ will be 17 minus X. Excuse me. So the product of these two partitions, of these two segments, will equal to the length of the altitude, which I don't know, I'm going to call that y. So that will equal to y squared. So just from this equation alone, there's not enough information for me to solve because there are two unknowns in this one equation. But there is another relationship that I have not used yet. If you look at this diagram, we're dealing with three right triangles. Let's focus our attention on the triangle with a hypotenuse of 15. From my understanding, we can apply the Pythagorean theorem. We can use x squared plus y squared, and that will equal to 15 squared. So now we have two equations and two unknowns. There's enough information for us to solve for both x and y. There's no need for us to actually solve for y, but if you really wanted to, we can solve for y as well. Our goal is to just figure out what x is. So what I'm going to do is I'm going to isolate y squared in the second equation. And if I do that, I'll end up with 15 squared minus x squared. And what I can do with this then is I can then substitute that back into the first equation. So 17 minus x times x will equal to 15 squared minus x squared, because I'm replacing y squared with 15 squared minus x squared. And then if I distribute the x on the left-hand side there, I'll end up with 17x minus x squared is equal to 15 squared minus x squared. We end up with negative x squared on both sides of the equation. So if I add x squared to both sides, I'll end up with 17x is equal to 15 squared. And if I divide both sides by 17, I will have answered the question. So let's enter this into the calculator, because it says for us to determine to the nearest tenth what the value of x is. So if I take my calculator, let's do 15 squared divided by 17. It'll be 13.2 to the nearest tenth, right? Yes. So that means this is approximately 13.2.